So we're going to take a look at solving equations where we have variables on both sides of our equation. So just like before, we want to always simplify both sides of our equation before we start solving for whatever variable we have. When we're moving terms that have variables, we're going to move them in a very similar way that we move just constant numbers. So we're going to be working with addition and subtraction to be moving these, depending on whether or not that term is positive or negative. So one little tip, if you move the variable that has the lower or lesser coefficient, that'll give us a positive coefficient after we move it and make our lives a little easier, but it's absolutely not necessary. You can move either and get the same answer. Okay, let's start solving some of these guys. So we have 2x plus 5 equals 4x minus 13. So my goal is to get all of the terms with x on one side and all of the terms without x on the other side. So I'm going to start by moving my constants. So I'm going to choose to move this 5. Really doesn't matter which one. I'm going to subtract 5 from both sides. So that's going to add to 0 over there. All right, and we have 2x equals 4x minus 18 now. All right, so everything that's a constant, right, a number without a variable, is on the right-hand side. Now I want to move my terms with variables to the left-hand side, or with x's. So that's this guy right here, my 4x. All right, it's a positive 4x. So I'm going to subtract it from both sides. Anything plus its opposite is just 0. So 4x minus 4x, or 4x plus negative 4x, that's just 0. And then we're just going to deal with this left-hand side by combining like terms. So 2 minus 4 is negative 2x. All right, and then solving as per usual, divide both sides by negative 2, and we get x equals, oops, not 6, 9. All right, let's try another one. So I see that I need to distribute before dealing with anything else here. So we're going to go ahead and do that. We'll get 2x minus 10 equals 5x plus 5. All right. And I want to go ahead and move everything to all of my constants to one side. So I'm going to do this a little bit different. I'm going to choose to work from the right-hand side this time. Not for any particular reason other than because I can, and it's good to see different ways of doing things. So I'm going to subtract the 5 from both sides. And then we're going to get 2x minus 15 equals 5x, because this added to 0. All right, now I want my terms with x on the right. So we're going to subtract 2x from both sides. Zero's out over here on the right. And we're left with negative 15 equals 5 minus 2 is 3x. All right, dividing both sides by 3, we find that negative 5 equals x. And I can go ahead and switch that around to read more normally, x equals negative 5. That's that symmetric property. Okay, I'm going to do one more example and then we're actually going to move on. So we're not going to do all of these examples. They're pretty repetitive after a certain time. All right. So let's take a look here. We got a lot of simplifying to do. So first, we're going to distribute. So we're going to end up with a 6x plus 21 minus 13 equals 10x minus 4 plus 4. Now we want to combine like terms. So on the left-hand side, we got this 21 and negative 13. So we're going to get 6x plus 8. And then on the right-hand side, we got a negative 4 and a positive 4. Well, anything plus its opposite is just 0. So that's just going to be 0, and we're going to be left with 10x. Okay, so let's keep solving. So I already have my constant be the only constant on one side. So I'm going to choose to move this 6x to group my terms with x on the other side. So we're going to end up with 8 equals 4x. Divide both sides by, not by 2, by 4. Cancels to 1 on the right-hand side. We get 2 equals x, or using the symmetric property, x equals 2. All right, let's take a look at something more. So we don't always get a number as our solution to these problems, okay? There are a couple of special cases, and this happens if a variable cancels each other out. So that means that we end up with no variables and only numbers. We're going to have two possible cases. First case is we're going to end up with a statement that's always going to be true, such as 24 equals 24. That means that no matter what number I substitute in for x, we're going to get a solution that's always true. So all real numbers are going to be a solution to the equation. I can substitute anything in for x and I will always get something true. Case 2, we're going to get a statement that is never true, like 24 equals 36. That means that there is no solution. There's no number that I could substitute in for x that ever makes that statement true. Okay, so let's look at how this happens and what it looks like when it does. So we have an equation here and we need to distribute to start simplifying. So we get 3x plus 5 equals 3x plus 12. And you might already notice something about this where our x's have the same coefficient, right? So that's going to come into play a little later on. So I'm going to get my constants grouped on one side. I'm going to subtract 5 from both sides. That adds to 0, and I get 3x equals 3x plus 7. Now I want to get my x's all on one side. So I'm going to subtract this 3x on both sides. It zeroes out here and here. So we get 0 equals 7. Well, that's never true, right? 0 will never equal 7. So that means that we will have no solution to this problem. All right, no solution. So we can even test that. You can pick a couple of numbers and plug them in and see if they work. So let's say, what if x was 2? Well, we'd have 3 times 2 plus 5, and we're saying that would be equal to 3 times 2 plus 4. All right, well, 3 times 2 is 6, plus 5 would be 11. 2 plus 4 is 6, times 3 is 18. Not true. Does not work. That's not true. All right, so we can't really plug anything in there. Now, that's not a strategy to solve these. It's just sort of taking a look at it and seeing, you know, I picked a number, I couldn't plug it in, and I said that there were no solutions to begin with. All right, let's look at another one. Okay, so I'm going to start simplifying. So on the left-hand side, I'm going to distribute, and we're going to get 6x minus 8. And on the right-hand side, I'm going to combine like terms, 6x minus 8. So you might notice a couple things about this, right? We got some similarities between the left and the right-hand side. So I'm going to try to group my variables. I'm going to subtract 6x from both sides. So that zeroes out on the left, and I'm left with negative 8 equals, and it zeroes out on the right, negative 8. Well, negative 8 always equals negative 8. Yeah, that's true. So that means we're going to have all real numbers as our solution. And if you want to shorthand that, you can use set notation, and you can use this double barred R, which is the shorthand for the group of real numbers. And this right here would say the set of all real numbers is your solutions to this equation. So let's just check this. Let's pick a random number. Let's pick 3. All right, and plug it in and see what happens, because we're saying all real numbers are solutions. So we could really pick anything. We could pick 1/2, but we're going to pick 3. So 2 times 3 times 3 minus 4, and we're really hoping that that equals 2 times 3 minus 8 plus 4 times 3. All right, so let's work with this. 3 times 3 is 9. 9 minus 4 is 5. 5 times 2 is 10. All right, and let's do the other side. All right, that needs to look more like subtraction. All right, I'm going to do this in 2 steps. 2 times 3 is 6. And 4 times 3 is 12. So now we have 6 minus 8 plus 12. And that does, in fact, give us 10. That works. It was a solution. So again, that's not a strategy for claiming that it's all real solutions. It's just kind of showing that I picked something random and it worked. Okay, so 2 special cases, either true, all real numbers, or never true, or false and no solution.